So one of the cool things we can do with linear algebra is take a look at some sports analytics stuff. So today in the lab we're going to be talking about how we can develop a sports ranking system using linear algebra. So the most basic way that we rank teams is through win percentage. So win percentage is just the number of games that a team has won divided by the number of games that the team has played. So we might want to be careful about looking at something where we're only looking at win percentage. We might not be looking at strength of schedule. Whether or not a team played home or away. What the weather was like. Injuries that the team may have had during a win or a loss. And all sorts of other things. So one reason this may not work out so well is that there's no way to distinguish that strength of schedule. So Team A might play only one game and win that one game, and then they have a win percentage of 100%. Well, Team B might play 100 games and win 99 of them, which gives them a percentage of 99%. So if we only are looking at win percentage, we'd rank Team A over Team B, but maybe that's not fair. Similarly, if we're looking at Team C and they play and win all 100 of their games, they would have the same win percentage as Team A. So is it fair to give them the same ranking as A? We want to figure out how we can distinguish between undefeated teams with difficult schedules versus undefeated teams with maybe a weaker conference. It turns out that linear algebra is going to help us with this. So before we discuss our ranking methods, we want to kind of talk about organizing some of this data. So suppose we have 4 teams, A, B, C, and D, and we have Team A beating B and D, and also C in this case, and Team D beating D and B, and then D beats B, A, B, C, and D. This is going to be sometimes called the poor sportsmanship graph, and what we're going to do is if Team A beats B, C, and D, we're going to have an arrow from A pointing to B, pointing to C, pointing to D. And so basically we're pointing at the people that we beat and saying, haha, you lost, you're bad. Not really a good sportsman, but it does help us in drawing this graph. So if we looked at trying to rank these teams, this one's actually kind of simple. So maybe the rank, team, name, maybe just team. Team 1, the first best team should be Team A. They beat everybody else. After that, C should be the next best team because they beat B, D, and they only lost to A, who was the best. D beats B, and poor B is going to be in last place. All right, so there's one kind of easy system for us to try to go ahead and rank. Well, let's look at another system to try to rank. So here we've got A losing to F, and then B and C and D are all in this conference, similar to how we had this before. And we've got E kind of dominating this conference over here. So take a minute, pause the video, and determine what you think the ranking of these teams should be, and maybe defend it in the discussion boards. All right. So there's kind of two main camps of thinking about this. You can think of it as this conference definitely is better than this conference. So even the lowest win percentage team should be higher here. We can kind of think of this as the transitive property. And the other way to think about it is straight win percentage. So let's do the transitive property here. If we're talking about the transitive property, we can have rank and the team over here. Number 1 team should be E. E beats everybody they've played against, and so E should be number 1. If we're looking at the transitive property, number 2, we're saying that everybody over here is better than everybody else over here because the worst team here beat the best team over here. So we'd the next best team over here, which would be G, followed by H, and then last but not least, F. And then we'd go over to this other bracket, and we'd see that in 5th place we should have A, in 6th place is going to be C, 7th could be D, and 8th place could be poor B. But we also could do straight win percentage. So again, we'll take our rank and our team. So 1, 2, 3, 4, 5, 6, 7, 8. So taking a look at here, E wins 100% of their games. A wins 75% of their games. G wins 66.7 approximately percent of their games. H only wins 33.3%. F only wins 25%. D, it looks like, wins twice, or loses twice but wins once, so they also have 33.3% win percentage. And then C, it looks like, also plays 3 times and wins 66.7%. And then poor B has a 0% win percentage. So looking at these win percentages then, the first place team should very clearly be E. And then looking at win percentage, the next best team is A. Now from here we have a bunch of places where we match up. And now here, as a tie break, we can use this transitive property. So here, G would be next, followed by C. Then H would be next, followed by D. Then F would be next. And then poor B is in last place. You're going to hear me say that a lot today. Poor old B. So note that in this system, even though F beats A is still the number 2 team, and F is still second from the bottom. So different ways of thinking about it, but it's kind of hard for us to maybe agree at this point using kind of these very straightforward methods. So that actually is easier to rank than most systems, but oftentimes we're not going to have something that's so nice. If we tried to rank these systems over here, we're going to end up with something that's a bit more challenging. So maybe you can talk about on the discussion boards. This is a good discussion board topic. Why it is that we would want to go ahead and pick whatever ranking it is that we have, and how we would go ahead and create those rankings. So our goal as sports analysts isn't just to figure out which is the best team and which is the worst team. So here we agreed on the best and the worst regarding our method. We want to rank everybody in between. And so this is similar to a task Google has of trying to figure out which pages to put at the top of the search engine when you search up a certain phrase. But sports ranking can be a little bit tougher because we have to rely on both luck and skill. So there are 2 methods we're going to look at today. The first one's going to be kind of straightforward, and the second one's going to use least squares. So the first method is going to be known as the Coley method. So as part of his mathematics PhD dissertation, Dr. Wesley Coley developed a method to rank teams in a way that incorporates strength of schedule that can make it a little more accurate than win percentage. Here's why he feels that it's more accurate. At the start of the season, a team's win percentage would be 0/0, but that's something that's undefined. So the Coley method says that a team that hasn't played a game should have a rating of 50%, so a 50-50 chance that that team will win or lose. Coley also wants to make sure that the average of all ratings be roughly 0.5. So we want to go ahead and adjust how we calculate our win percentage. So normally win percentage is going to be the number of wins divided by the total number of games played. The Coley win percentage is instead going to be the number of wins plus 1 divided by the total number of games plus 2. So then after each game, the denominator is going to increase by 1, the loser rating goes down, and the winner rating goes up. So to set up this system, Coley is going to set the rating for each of the teams R sub I equal to their Coley win percentage. So that it is R sub I equals win sub I plus 1 divided by total number of games played sub I plus 2. So each of these is for each of the different teams. The I will denote which team it is we're talking about. In order to incorporate strength of schedule, Coley does a little bit of an algebraic manipulation. Here we're saying L sub I is going to denote the total number of losses for a team. So notice that the rating is equal to the wins plus 1 divided by the games played plus 2. So we're going to multiply this over here. And then we're going to do something that gets used a lot in upper level analysis classes, which is kind of create a weird ghost term almost. So we're taking this win percentage and we're saying it's the wins percentage, or number of wins, and we're saying it's the number of wins over 2 plus the number of wins over 2. And then we're also adding and subtracting this term here of the losses over 2 minus the losses over 2. And so here we haven't added anything, it's basically 0, and here we're just splitting up a term we already have. Rearranging this equation, we can get the 1 plus wins minus losses over 2 plus wins plus losses over 2. Notice that wins plus losses is just total number of games played. So this is where Coley is going to make his adjustment in order to incorporate the strength of schedule. So we're going to replace wins plus losses over 2 with the sum of the ratings of the teams that were played by Team I. We're going to note that as S. So when we're creating our system of equations, we're going to be taking 2 plus the total number of games played times the rating. The ratings are going to be our things we're solving for. So R sub I, the R sub I's are the unknowns for our systems of equations. And here this S is going to be the sums of the ratings of the teams played by Team I. So let's walk through an example. Say that Team A beats B, C beats A, and C beats B, and then B beats C. We want to use the Coley method to have the following system of equations. So this all can be a little bit of gobbledygook, which is why it really helps to have kind of a picture. So we've got 3 teams, A, B, and C. All right, so it says A beats B, so we'll draw an arrow going from A to B. C beats A, so from C to A. C beats B, and B beats C. So using the Coley method, each of these equations is going to be 2 plus the total number of games that team played. So remember, it's 2 plus T sub I times R sub I equals 1 plus W sub I minus L sub I over 2 plus S, where this is the sum of the ratings of the teams they played. So to go through this one, 2 plus 2 total games for A equals 1 plus 1 win minus 1 loss over 2, plus they played B and C once each, so plus RB and plus RC. For the next equation, we have 2 plus the 3 games that B played times its rating equals 1 plus 1 minus 2, so 1 win and 2 losses, over 2 plus the rating for A, who they played once, plus 2 times the rating of C, because they played C 2 times. And then for RC, we get 2 plus 3 RC, so C played 3 games, equals 1 plus 2 wins for C minus 1 loss, all divided by 2. And then they played A once and B twice, so plus RA and plus 2 RB. Now remember that when we have a system of equations, we like to have all of our variables, our unknowns on the left, and our constant terms on the right. So we can rewrite these 3 equations as such. So we get, for the first one, 4RA minus RB minus RC equals 1. And so it's 1 because we had 1 plus 1 minus 1 over 2. And then you can follow similar logic to get these other two equations from these two as well. So now we have a nice symmetric matrix system, and we end up with this system of equations, and getting the reduced row echelon form of this. So remember, all we're doing is this means that we're taking 4, -1, -1, 1, -1, 5, -2, 0.5, and -1, -2, 5, 1.5, and we're getting the reduced row echelon form of that. And that should give us this as a solution. So here we're going to go ahead and make our rankings ordered by who has the highest Coley rating first, and then go from there. So we should have 1, 2, and 3. So team with rank 1 should be team C. The team with a rank 2 should be A, since they have the second highest win rating. And then our last rating should be poor B. B has the last score again. All right, and so that's how we'd use the Coley method. So it comes down to figuring out basically how to set up each equation, getting the variables over to the right side, and then row reducing our system. So this one is decently straightforward. So if you want to talk about some things on the discussion board, just to make sure you're following along, you can go ahead and try these and discuss on the discussion board. And so that'll be kind of just some extra examples of the Coley method. So that's our first method that we're going to use in order to try to do a little bit of sports ranking. So suppose that instead of looking at just flat win versus flat loss, we want to incorporate the score. So there's a question up here that talks about how much you beat a team by, and the Coley method doesn't really care about what these numbers are. This 17, these 10s, and this 5, they don't really mean anything to the Coley method. But for the Massey method, it's actually really important. So the Massey method was created by Kenneth Massey, and it creates a system of equations using the score of the games played. And so how the equations work for the Massey method is we're going to have the difference in ratings is going to correlate to the point differential. So here it's represented by Ri minus Rj equals B sub k. So in other words, this is saying that team I beat team J by whatever B sub k is point-wise. And so these are going to be the things we use to create our system of equations. So let's take a look at an example. Suppose we have 3 teams, A, B, and C, and then A beats B by 7, so A minus B equals 7. C beats A by 1, so C minus A equals 1. C beats B by 1, so C minus B equals 1. And B beats C by 10, so B minus C equals 10. This gives us this system of equations, and this would give us the following matrix system to try to look at. So what you might notice is that when we look at this system of equations, typically what's going to happen here is because there are more games than we have number of teams, we're going to have more rows than columns. What happens is we get an inconsistent system where we have no solutions. And so if we don't actually have a solution, we want to get an approximate solution. And what did we say we can use to approximate a solution? That's right, least squares. So we want to use least squares in order to try to solve this system. And so here what we would do is we would create our matrix A. So we would have, in this case, a 4 by 3. And so we get 1, -1, 0, -1, 0, 1, 0, -1, 1, and 0, 1, -1. So That row's good, that row's good, that row's good, and that row's good. And then we need to make our other vector. In this case, this R gets 7, 1, 1, 10. And so we would want to get A transpose A. So in this case, we're going to be labeling this as A and this as B. And so A transpose A gives us 2, negative 1, negative 1, negative 1, 3, negative 2, and negative 1, negative 2, 3. And A transpose B will end up giving us A transpose B. We will get 6, 2, negative 8. So if we take and create an augmented matrix with both of these, we should hopefully get something workable. So we have 3 rows, 4 columns. We get 2, negative 1, negative 1, and 6, negative 1, 3, negative 2, 2, negative 1, negative 2, 3, and negative 8. So just to verify, C does indeed give us the matrix we were hoping for. And so if we get the reduced row echelon form of C, well, that's not good. Notice here that we've got a free variable and we get infinitely many solutions. Well, that's a problem. That's a new problem. In order to fix this, what we're going to do is we're going to replace the last row of our matrix with a row of all ones except for the last entry, which is going to be 0. And the short version is that it ends up forcing our ratings to sum to 0, and it ends up being something that works out pretty well for us. So now we're going to edit C, and so the instructions say we want to take the last row and make it 1, 1, 1, 0. So this is what C should now look like. We're just replacing the last row that we get from the augmented thing with 1s followed by a 0. And if we get the reduced row echelon form, what we're going to get is that RA equals 2, RB equals 0, and RC equals negative 2. So here, now our rankings are going to be a little different for this system. The first team is going to be A, second place team will be B, and our third place team will be C with the lowest rating. So this lets us incorporate score and lets us incorporate kind of who beats who and strength of schedule. But there are a lot of other things we might want to consider incorporating into our systems. And so one of the things we might want to talk about is blowouts for games. So suppose we want to make it so that if a blowout happens, we want to cap the number of points you can win by. For the Massey method, this is actually pretty easy. All we have to do is say, if we consider winning by more than 15 a blowout, we're going to cap the win difference at 15. And we could just kind of cap that size of the win in order to adjust properly for blowouts. One other thing we might want to do is weight our scores for our games, say based on when during the season they happen, if it's a rivalry game, something of that nature. So suppose that we want to weight our games based on the time of year they happen. So we're saying that A beats B by 7 in the mid-season, C beats A by 1 early in the season, C beats B by 1 mid-season, and B beats C by 10 late season. And we want to go ahead and weight these as 0.5 for an early game, 1 for a mid game, and 5 for a late game. Now, if we're using a normal unweighted Massey system with a 10-point cap, then this would be our normal system that we would end up getting. And so this is similar to the example we saw on the previous page. But if we want to go ahead and perform these weightings, we're going to actually use something called a weight matrix to go ahead and multiply by both sides here. And what this weight matrix will do is it'll be a square matrix that has only entries on the diagonal, and those entries are going to correspond to what weight we have. So the first game was mid-season, so we wanted to have a weight of 1. The second game was early in the season, we wanted to have a weight of 0.5. The third game was mid-season, so it's got a weight of 1. And the last game was late season, so we said we wanted to have a weighting of 5 for that. And so we multiply by this weight matrix on both sides of the equal sign here, and we get a new system from this. We still are going to need to go ahead and do our least squares solution and do our replacement, but we had to make this adjustment before we went ahead and did all of that. So now we can set up the least squares solution by doing A transpose AX equals A transpose B, and this gives us this matrix times this vector equals this other matrix, so our solution vector. And remember that when we're doing the Massey method, so I want to point out this replacing the last row of our matrix with 1s and 0 only do this for the Massey method. Right, in general, we're not doing that for least squares. So this is what we get when we make this replacement. And when we solve this system, we end up with this rating system. And so here we get that Team A is in first, Team B is in second, and Team C is going to be in last. We also can go ahead and perform this weighting by looking at the Coley method as well. So remember, for Coley, we're not too concerned with the point differentials. We just care who wins and who loses. And so when we're going and setting up these wins and these losses and total numbers of games played, we have to make sure to weight each of those as well. So in this example, Team A plays a single early game, a mid-season game, and a late game. So they played 1 times 0. So I want to maybe point out, we can change what the weights are between systems. The weights are kind of arbitrarily chosen. And so what we choose for weights might actually change what our outcome is for the system. So for Team A, if we read this paragraph, Team A plays 1 game early, so 1 times 0. They play 1 game in the middle of the season, so 1 times 1. They play 1 game late, so 1 times 1.5. A total of 2.5 weighted games. And so remember, we get 2 plus 2.5 for this part, and then we also keep into account with how many times they played each team. And those number of times will also be weighted. And so we'll end up getting a weighted system for Coley, and we can kind of go through it. So if you have questions on how we get this system and how we get this answer, feel free to ask about it on the discussion board. All right, so a lot of opportunities to go ahead and get some discussion board points. Now I want to point out that after the next page, so the next page is going to have a lot of exercises. After those exercises are going to be some sample problems, so kind of seeing a little bit more of some things worked out. In the past, people have said that they maybe didn't see examples of this in order to really get a feel for it. So hopefully those extra worked out problems can help, and you can always ask about them on the discussion board. So on the next page are a bunch of questions that we can answer. Again, try, discuss on the discussion board. So maybe you guys can set these up. Maybe if you're not sure how to set it up, you can kind of work together to figure out exactly how you would go ahead and do that. Ignore this thing where it says bonus. bonus would be for if we were turning this in for points, but remember, we're not turning the labs in for points for this class. We're just focused on getting them, or giving opportunities to kind of play around with the math a little bit more. And then after we get to through this page, there are, on the next page, extra examples if you guys want to look at. So give it a try, have some fun with the Coley and the Massey method, and maybe even try to come up with your own system. And that would be something fun to talk about on the discussion boards as well. So lots of ways to use linear algebra to do some sports ranking. It's another fun application.